Okay. Uh, so are we ready? Harish, okay?
Yes, I'm ready, ma'am.
Okay. So transmit power. Transmit power equal to transmit power equal to Rx sensitivity plus total loss plus maintenance margin. Okay. Let's do again the some other example. Okay. So here this is again a 80-kilometer link. So we have a drum of 4 kilometer drum. Okay. So now let's start with again. We will find out the first one. We know okay, RX sensitivity. We know that from the vendor sheet, we found out a value minus 20 dB. Okay. So now we are going to find the total loss. Total loss.
Is that a range, right? Minus
That is a
80.
range. I looked at the vendor sheet and come up with one final value. You know that RX sensitivity, even though it is provided by vendor, it
Mm-hmm.
depends upon modulation and bandwidth. So we know the modulation and bandwidth from, and then we looked at the sheet. So we took this value as a reference, minus 20 dB.
Mm-hmm.
Okay, or any confusion?
Yeah, yeah.
Okay. So total loss. Now we need to calculate it. First, what we have to do? How many connectors are there?
Two.
Two connectors are there. So each connector is taking 0.5 dB. And then for 4 kilometer stitch and 80 means how many splice point is there?
Four. Oh,
No, 20. 4 kilometer drum, I am saying that. No? So 80 by
okay.
4.
Yeah, one is 40, no, two only, no?
Yes, 20. I don't know why the pencil is fluctuating.
Actually, like how you're using mouse or pencil, bro?
Uh, Mouse, pencil only, Harish.
Okay, okay,
I switched off the mouse.
okay.
Okay, so 20, 20 areas we need to 20 into what is the splice loss value? 0.5 plus
Mm.
um, what else is there? We need to find out. Okay, 80 kilometer and the attenuation 0.25 dB per kilometer. Right. So this is 1 plus 10, correct?
Yeah.
Mm. Plus
80
80
into.
into for this is
One doubt is that 0.25. Can you tell one time?
uh,
We put 0.25 there.
0.25. Yeah, this is Harish attenuation we discussed, no? So
Yeah.
every kilometer the light travels, it loses 0.25 dB power. So
You
we
said
have
zero
a
point
heating.
0.2, right? Okay. Hmm. Got it.
So that is
Is it 0.25 or 0.20?
uh, okay, whatever value we can change it now. No, I will give the reference values once again.
Okay.
Kabila, for Vivek Pankul, he's there. Okay. No. What is the question here?
It's 0.20 or 0.25.
Yesterday I said 20, is it?
Yeah.
Okay, then we keep 20. Don't worry about the values. Then it is 1.6. Okay. So the total loss is 12.6. Okay. Then what is the maintenance margin? Something wrong with things.
80 into 0.2 is 16.
16.
You put 1.6.
Yeah, I will change it. 1 second.
Okay.
So 80 into 0.20. So that is 1.6 only, right?
Okay.
Okay. So we got this. Okay. So yesterday I was talking about the car example. In the car example, uh,
Surendra,
yeah,
sorry. Sorry.
yeah,
It is showing 16.
uh,
80, 80 into 0 point.
20. Is it 16?
Yeah.
Okay. Then it is how much it is?
I,
26.27.
I
Correct?
used a calculator. Yeah.
Okay, okay. Good.
Yeah.
Okay, so maintenance margin is nothing but I told you you are not exactly fill the petrol based on your calculation. So you are going to add some more extra fuel that is for safety purpose, right? So
Yeah.
similarly, here also we are using the safety purpose concept here. So we assumed that this everything will be good and we need this much power now. But in future, there might be a fiber cuts. There might be a degradation in the laser light source. Because of that power, usually it is transmitting at 1 dB. It may not be transmitting exactly 1 dB. It might be 0.90 dB, something like that. So because of aging and the future fiber cuts, we need to accommodate those things also. So what we usually give is the extra fuel. By the industry standard, what they said is 3 to 6 dBm. Based on your, the network, so you can keep this as a maintenance margin or the future margin we used to call.
Okay.
Okay, so in our case, we will take 5 as a example.
Okay.
So here, another best example is I laid a fiber between city A and B. You 1 year, first year you didn't experience any fiber cut. Second year you experienced two, and third year. So you keep on maintaining a database. So based on that database from the past trend, you will come to know that you are expecting these many cuts at an average of two or one in the particular span. So based on that, you can come up with this maintenance margin. That is usually it's kind of a gut feeling only. So that is why they keep it as 3 to 6.
Okay.
By experience, you will come to know about this number. Okay. So what is the total thing? First one is our receiver sensitivity. that is minus 20 dB plus our what is a total loss 27 plus our maintenance margin. So if you consider 7 plus 5 equal to 12. So what is your transmit power? At least you should transmit 12 dB of 12 dB power. Will you agree that? Then only it will it
Yeah.
accommodate all the losses, receiver sensitivity value, and the maintenance margin. So yeah, the transmit power is calculated based on this one. But we have a constraint because what is the constraint that is? We have 5 dB to our transmit power ranges
Yeah, 5 dB to plus 5
plus
dB.
5 dB. So where we are, how much power we needed here? 12.
12.
So in that case, what is it possible or not? 12
No.
dB transmit power, we can't give it. Ultimately, what will happen? This link will not work. So in that case, what we have to do, we can't do anything with the loss because you are using the drum, the attenuation is same, connector is same, so you can't play with this parameter. You ruled out. RX sensitivity also, if you reduce the modulation or something, you can bring it down to a minus 22 or minus 25. Then also it will not work. You can't play around with it because this is also a limitation, minus 18 to minus 24 something, right?
Okay.
So now the maintenance margin, even if you don't consider this one also, you can't come within this range.
Yeah.
So in those cases, several spans will come like this. So in these kind of scenarios, what usually we do is, what is the option? Any thought on
We'll give 5.
uh, what is that?
We'll give 5 in transmitter first,
Uh,
and
then it will not reach,
middle
no?
stop. Yeah, middle stop, you will give again 5.
Okay. So what will happen? Okay, that is the case. So you are a 5, if you give 5, your signal will reach till here and then it will die down. So what you are saying, transmit again from here. Fine. So what is
Yeah.
the station is called then?
Transmission station.
Yes, we can call it as amplifier station
Amplifier station. Okay.
or ILA. The common word in US is ILA, inline amplifier.
Inline amp.
Okay. So, so if you introduce an amplifier, what will happen? This usually what amplify means it will boost the signal, correct?
Yes.
If by default, if you look at the amplifier, the vendor will give. So it will boost the signal by 20 dB. Like that they will say. I will show that. Okay, if you look at the amplifier, I will give you the codes when we study about the optical network components. So we saw so far the network only. What are all the components are there? Like transmitter side, what will be there? Laser light, LED light, and the receiver side, it will be photodiode or pin diode. And what is the standard of fiber optics? What is the amplifier, splitter, coupler? All those things we will start study. But for calculation purpose, what I'm saying is we will consider this amplifier will boost the signal. So if you are giving 0 dB power signal, then what you will get once it is input to the amplifier, out what will be the output signal?
5.
No, 20 dB.
But it will You cannot send 20 dB in fiber, right?
No, it is not. No, no, no. Okay. It is, yeah, very good. Very good. So this is actually dBm, 20 dBm. Okay, I will give you what is the difference between the dB and dBm. Okay. dB usually, we actually, when you are comparing the output power by input power. Here, both are in watts. So here, watts. But here, same output by input, it is in milliwatts. Okay, so this is even lesser value compared to the dBm value. So dBm is like a kilohertz, dBm is like a hertz.
Okay.
That's a good catch, yes. So that's why it's the right time to introduce the dB and dBm. Okay, so in this case, when we are going back to the same exercise, we put an amplifier here. Mm, 80 kilometers. So what is the transmit power is required? 12. So now the formula become Tx power equal to power equal to what is that? Rx sensitivity plus total loss plus maintenance.
Maintenance much.
Minus amplifier gain. Gain is nothing but you are 20 dBm. Okay, so here, mm, so same example, Rx sensitivity minus 20. This is how much it is? 27 plus maintenance margin 5 minus 20. So it is 7 plus 5 minus 20. It is 12 minus 20. It is minus 8.
I have a confusion here.
Yeah,
Okay.
very good. Mm.
So you're calculating everything in all in
DB, DB.
M.
Yeah, very good. I'm expecting this. For time being, you get this one. You understood we are just, even though both are in dB, dBm. For example, one simple logic I will tell you in logarithmic, what we are doing, if you are multiplying two numbers simply, the same in logarithmic, we are just adding it. Do you remember that when we studied logarithmic values?
No, I am very bad in maths.
No, this is a good question. Even I, after ChatGPT only, I cleared this. What is DB and DBM? I used to get confusion with that DB and DBM.
Okay.
But Harish is there. Harish is there? No. Okay. So, Sai, you note
Yeah.
down this part. I don't want to miss the flow. So, it is a big chapter. Definitely, it is a interesting point. What you said is, but this is the way we have to do. Why we are doing this is, we will take it in as a max class. Now. Just one part. But you should definitely know the difference between DB and DBM, but not at this stage because we have to still go some more things. Then you will clearly understand what is DB, where we are using DB, and where we are using DBM.
Uh, okay.
Okay, so
So for
you
now, I have to take like this.
like this, yes.
Okay.
But keep in mind, even if I will tell this two difference with the logarithmic values. Logarithmic values, I forgot it, but I understood it with ChatGPT help. Why we are just simply adding it, even though one unit is different, another unit is totally different.
Yeah.
Uh, I will explain that logic. So I will explain the difference between these two when we are discussing about the optical network components. As I said, the diode, laser, LED, coupler, splitter, all those things.
Okay.
Okay. So
Yeah.
what else we missed out in the? So is this good enough?
Yeah. It's -8. You're saying.
Ah,
So
-8.
transmission power is -8.
Ah,
So the formula is Rx sensitivity. We have to take from vendor.
ah. No.
Total.
What is your thought on this transmit power?
This is good, right?
Our range
It's
is -5 to
okay. Yeah.
+5.
It's
Ah,
not bad. It's
okay.
bad.
Yeah, I said no, not bad. Okay, but I said -8 is the which is a high power, -8 or -5. No?
-5.
-5 is the high power. So this is the low power. What as per calculation, low power is enough for the light to survive the 80-kilometer link. But there is no harm at all to fill the extra fuel. You can go with -5, -4 also, as long as you are not damaging the receiver.
Okay.
Now we will see what is the RX power. Okay, for example, you tell me a value because -8 is the lowest value, but the range is -5 to +5. You tell one value, we will take that and do the RX power calculation, whether it is damaging the receiver or not.
So you want me to give the RX sensitivity?
Yeah, this value. What transmit power we give. We calculated -8 is sufficient. So I
Yeah.
thought to cross the 400-kilometer desert link, I need 40-liter petrol. But I can fill only for 45 liters. The petrol bunk owner said, no, I can't fill 40. 45 only I can fill it up, 45 liters only, for example.
Yeah.
So, will it be a harm or harmful or harm? It's not harm. That is what
If
we are going to find it out, whether it is going to damage the high power, going to damage the receiver or not. So, if you want to find out the findings, the
RX power,
RX level. What is the RX level if we transmit? So Rx level is there is a formula for it. That is Tx power minus loss, correct? Minus maintenance margin minus connector loss. So okay, no, we will consider this one once again. Sorry. Minus loss plus amplifier gain What else we missed it? Hmm. Okay. So what is the transmit power you said?
Plus minus 4.
-4. Okay. What is the loss we have seen? 27, right?
Uh,
Total loss 27. Plus what is the amplifier gain?
we missed maintenance margin.
Oh, okay. Minus maintenance margin. Hmm. What is the amplifier gain? This is the amplifier we are using it, right? So
Yeah.
we are adding it minus maintenance margin is 5.
I think is it are you following Bodmer's rule?
What rule, Sai?
Bodmer's.
No, what is that?
So basically, you cannot put any like Bodmer's is first you have to. I also forgot, but first you have to do addition,
Okay.
and only we have to do subtraction.
Ah, yes, yes. Ah, okay, I got it. The multiplication. Yes, yes. Ah,
Yeah.
ah.
So here you put -5 after, right? That's what.
Actually, here it used to come. Since
Yeah,
I forgot it and you reminded me, I just added in the last. Yeah, you are right. After actually, it comes like this one: minus loss, minus main plus amplifier gain.
yeah,
Got it?
yeah,
Okay. So, so -4, loss is -27. Here -5. I will go with you.
yeah.
Minus
Plus
20.
20,
Yeah. Okay. Now what is it? 32, 36 minus 36 plus
plus 20.
20 equal to what is that? -16. So your receiving power is -16.
Yeah.
Yesterday you asked me, no, what is the range for the RX now? Yes, you asked me for the this
Yeah,
for receiver sensitivity, I guess.
yeah. dBm, you said.
Uh, yeah, let me find out the range with Google. One second. I'm searching it.
Yeah, yeah.
Yesterday you asked me, I remember it. What is the RX level range for the WTM link? Yeah, okay. That is RX level. Sorry, that range is -10 to -25
RX,
RX value. Okay.
dBm.
dBm. dBm. Correct. dBm.
Is it RX sensitivity or
No,
RX?
RX. RX value. RX value.
Above one, what you have given is it RX sensitivity?
No, no, RX value. RX sensitivity, yesterday we gave it.
Yeah,
Uh,
that is what I'm asking.
yes, this one I will change it one second.
Yeah,
Okay. Is that okay?
yeah,
Now we got transmitter range, RX sensitivity range, as well as the um, this one also RX lane. Here it is. minus 10 to minus minus 25. Okay, done. So, okay. Now, are we, is that we are in the range or not? Will this damage the receiver? This RX, what we have found out now.
Not that one. This side you are.
You,
Yeah.
very good. Ah, this one.
Yeah.
Will it hit or it will not hit?
No.
It will not hit
Yeah.
because our range is minus 10 to minus 28 now. So that is within the range. So that is, so this is
25.
how, yeah.
Yeah.
So we should remember these two things. You have to do either way, Sai. So first thing, you need to find out the TX value. So suddenly, if there is a condition that you are introducing an amplifier, then you need to calculate it. Then you need to ensure it. What is
Here
the
also, I think, okay, minus 20.
hmm.
Okay, again, that's fine. Yeah.
Another important thing is actually where you will keep the amplifier. What is the ideal
When the,
location?
yeah,
When the signal is becoming worst, there you want to put the amplifier.
yes,
Actually, for that also, there is a formula for it. But I want to introduce, don't want to introduce that formula now. Uh,
okay,
okay. So, uh, for example, I called this A to B as one span. Now, if you put an amplifier in between any location, in between any of this location, it will become two span. This is one span. This is another span.
I didn't got you.
Okay. Actually, I often use the word called span. Span means the starting point to the end point, where
Spam,
you are transmitting.
SPA.
SPAN. Yeah.
Okay,
SPAN. Yeah.
okay. N, span, okay.
That's span. So, is which segment we called span is maybe a it can be between transmitter and a receiver, or it can be between a transmitter to an amplifier, or an amplifier to another receiver.
Okay,
So this is so now without amplifier, there will be one span. With
yeah,
amplifier, this is also one span. This is also one span. Okay.
yeah,
So length of the span, how to calculate it? That is another mathematical formula is there, where to keep this amplifier so that it will be very good for good for the receiver. Okay, for example, if you keep very close to here, what will happen? Logically, you don't calculate anything. If you keep here,
yeah,
what will happen? It will be waste, right? So because you almost reached the destination. Here you don't need to what is that? Regenerate yourself. So
yeah,
so in between itself, take rest or regenerate yourself or refresh yourself and then go for a longer distance. No, if you are traveling, when you are reaching almost close to the destination, you won't take a rest or refresh yourself, right? So this one.
yeah,
So, and another point is if you keep the amplifier very close to the receiver or here, what will happen? It will pump more power because if 5 dB comes in, then 20 plus 5, 25, it will become 25 dB. So it may damage the receiver. So keeping the amplifier close to the transmitter or close to the receiver is not ideal because it is amplifying the incoming power level. So somewhere in the middle, you need to keep it up so that we will get a healthy communication.
Yeah.
That is calculated in a span length calculation. So that when we introduce the components, we will study that. Okay.
Okay.
And what else we missed out in the thing? Do you remember?
Dispersion.
Ah, so in the losses one, attenuation we saw that, fiber loss we saw that, dispersion is not. Okay. What is dispersion? Dispersion is which is called as the broadening of pulse. Do you say that broadening of pulse? What is dispersion? So over a period of time, it goes like this, right?
Yeah.
So I have a question for you. Does dispersion means loss of power or loss of quality?
Loss of quality.
Very good. Why?
Why? Because the power, it was reaching the
Yes,
same strength, but it was dispersing there, right?
right.
The quality was gone.
Very good. So it is loss of quality signal light.
Surendran, I joined back.
Ah,
Sorry.
okay, okay, Harish.
So the issue is, that Smart Folks president actually called me.
Ah,
Yeah, we were talking, and in the meanwhile, he got a call from the HR. So he told, I have to make a long conversation with you. So I'll again get back to you. I'll call you again shortly after I attend the call. He told me. He
okay.
was asking, it is about that H1B. We need to make a decision whether to file or not. So can you tell your background and all of those things? He was asking me
Ah,
what are you doing, what things you did like that and all. So I'm still waiting for his call actually. He might
oh,
call any.
anytime. Okay.
Yeah. So I don't know whether they will do or not, but I'm trying my best.
Ah,
Just checking actually if they can able to do or not. I'm just checking. So once they told, on Monday they told no, right? So again I've requested them on Tuesday.
ah,
They were still, I know there, and then yesterday evening I got a call from one guy from HR. He's an analyst there.
okay.
So he called me, and then he told, "We'll do it." I mean, did HR told you anything about it? He asked. I told no, I did not hear back from her, but I did message her. I requested her again.
Oh,
But yeah, we are filing through. We are filing actually. So is it okay if we change that SOC code? According to that, is it okay if we change like that? And then he
oh,
asked me just provide the job description. Actually, immediately he asked me. I just provided him yesterday evening. He told, "Okay, I will check and tell you."
mm,
Today I did not hear back from him, so I just called him. He did not pick, so I just messaged him again. Is there any update about H1B?
mm,
He just replied like, "I will update you tomorrow," like that.
mm.
So yeah, I don't know. It looks like this Smart Folks Inc. President. He told he has 25 years. They are there. He has 25 years there in this company. He
Oh,
told.
oh,
So person. So I'm not sure actually what he's going to tell.
mm,
Uh,
mm, mm,
Going to reject. I don't know.
mm,
He was telling this salary, this wage level is the
mm,
biggest issue there.
mm, mm.
Surendran, I'm getting call again. I'll
Okay.
come.
Ah,
Sorry, actually, sorry. Yeah.
okay. And for the dispersion, sorry, 1 second, I will find out my note. The
Yeah.
formula for it. Uh, for dispersion penalty, dispersion actually, in terms of loss, we used to call it as penalty. Um, dispersion penalty. Okay. So that is the formula is 1.8 into B bandwidth into L fiber length into dispersion coefficient. Dispersion coefficient into laser spectral width. Square divided by 10 power 6. The result is in dBm. Okay. So this value bandwidth, this is nothing but your how much speed you are carrying in that fiber. It may be 10, 100 gigabit
Bandwidth
per
is
second.
speed. Modulus is speed, right?
Yeah, speed.
Modulus is speed, right?
This is you are talking about the bandwidth.
Yeah, bandwidth is not speed, right?
Correct. True. We will say this fellow has given like, oh, bit rate. Sorry. Bit rate. You are right. Very good, Sai. So bitrate is 100, same like speed only. 100
Okay.
or 1000 GB or 1 TB, whatever it is. Okay.
Okay.
Fiber length, we know that our case it is 80 kilometer. Dispersion coefficient. So for every every bandwidth speed, there is a coefficient. They mentioned it as in terms of nanometer per second. Um, pico, this value, they have a table. Okay, I will give you the table. It usually it comes like 1.6 into 10 power. Uh, dispersion penalty. Where is it? Okay, for 10 gigabit, it is 17.17 picoseconds per nanometer. That is uh, actually this one how they measured it means nanometer. This is distance psi. So your light is traveling over a distance. If it is traveling over the distance, how much it is deviating? This is measured in terms of seconds. This is the distance. Okay. So that is why they gave this value. For every 1 nanometer it travels, it broadens by 17 picoseconds.
Mm-hmm.
You got it? That much small, minute deviation also they are capturing it.
Yeah.
Okay. So then later laser spectral value, this is given by the vendor. You can see it in the this one. For sample value, how much they have given. Um, 0.1 nanometer. Laser spectral width. What it means is the laser can able to generate. What it means is, for example, you are radiating in 1550 nanometer. That is in one wave. Okay. The next wave is 1550.1, then dot 2. So what we mean by laser spectral width is the minimum bandwidth. Spectral width is nothing but your same bandwidth, the width of the road. The difference between these two frequencies is zero point 0.1. That is what they are mentioning. Do you remember I explained this concept, the bandwidth concept, long back in the introduction section? Uh,
Yeah.
what example I have given?
If it have to go like more vehicles have to go, it should have a more
No,
bandwidth.
frequency and bandwidth. So, say city A and B. If you want to travel from city A to city B, there are three different roads are there. One is gully road, second is state highway, third is national highway.
Oh
Correct?
yeah, yeah,
Those three
yeah,
roads
yeah.
are different frequencies. Only difference is gully road is width is small, state highway bit larger, national highway
Mhm.
is higher. So that is the one. So we here what they mean by this one laser bandwidth is the laser can generate frequency even as low as zero point 0.1 nanometer. This is 1550 nanometer. This is 1.5501 nanometer. This is the thing. So don't worry. When we study about
I
laser, we will see.
Yeah, I have a doubt.
Hmm.
So these calculations right now we are doing it, or it's already automated?
All are automated. Now
Okay.
you need
Thank God.
but
Yeah.
but
Uh, Surendra, I can join back. Sorry to interrupt this call. I'm
no,
taking other calls actually. I'm sorry.
no
But I
worries.
have an update which I will tell. I can tell you after this
Okay,
our our meeting. Yeah.
cool, cool. So actually, why I am teaching this formula is, uh, so tomorrow when you are actually planning for it, if you it will give you the final result. See, there in our earlier case, we got -8. We didn't fix this value. So what is the option? We try to adjust this one, and this one. Finally, okay, nothing is worked out. So we introduced an amplifier. Okay, introducing an amplifier is like a huge cost. Okay, so we try to fix it along with these parameters. So this is how you are tackling it in even in the interviews. So if you know inside the formula what is there, then you can tell. So for example, I will ask you how you decide the transmit power. Then you can say transmit power is depends on the RX sensitivity, total loss, maintenance margin. Is there a dependency on RX sensitivity? Yes, RX sensitivity, even though vendor is given it, it is depend on bandwidth and this one. So it will help you in when you are working it, even though it gives you a complete results. You need to when you are not getting a desired result, when there is a need for a human intervention to play with these parameters, you should know what is there inside, what
Okay.
parameters affect those things.
Okay. Okay. But dispersion, it is very difficult.
Really hard, I know.
I'm not getting it. I was concentrating, but
But the good news is dispersion penalty also. Nowadays, vendors are coming with the sheet, same like dispersion. This one, what is that? RX sensitivity for this bit rate for fiber length, they won't give it, but their range they will give it. But that's why
okay.
the tool will do the calculation for you.
Okay.
Okay, and finally, in the main this one, we the last parameter is optical return loss. It is part of the loss. Okay, what does it means? For every connector, we are using it in the mode. When the light gets into the connector, part of the light is reflected back and it comes to the originator itself. For example, it is transmitting. It goes all the way and go to the B. And some energy is coming back to this one also. It is very minimum, very meager. So the typical value is 0.1 to 0.5. No, it is 3. 1 second. Dispersion overall penalty is 0.1 to 0.5. Yes. So you need to accommodate this as well in your loss.
It is a written law.
A written loss, yes.
Written law. So,
Optical written loss. Some of the light is reflected in the connector and returns back to the origin transmitter again. So that will interfere the signal partly. So that loss is between
I
0.
have a I have a doubt.
Yes.
If it's 80 kilometers,
Hmm.
already the power was gone there,
Ah,
and everything is like very low.
ah.
Why again it will go back to the transmitter?
Very good. Yes. It will, as much as it can travel, but it will do the damage. For example, up to this point, it may travel means
Okay.
it will do the damage. Yes.
Okay. It will not travel up to the
Yeah, yes, yes.
transmitter. Okay.
Super, sir. Very good.
Yeah.
Okay, so now if I give a link, then now you can able to calculate all these things, right?
Yeah.
So I will give you 5 problems today. I will give the formulas as well. Do it
Okay.
and come back for the next class. So
Okay.
we are not going to end with optical formula. This is the straight formula. Still, we are going to use the one more formula. What is that is? Okay. So I said I got a receiving power level, but
So I have
yeah,
a doubt.
yeah.
So you are saying three formulas
Hmm.
right now. Till now,
No,
you
I
are saying
developed from it is like a software development minimum viable feature, and then I come up with complete formula.
okay.
The first
So
formula we didn't add
transmitter.
the dispersion, we didn't add the ORL. So finally, we are going to add everything. I will give you the final formula
Okay.
in the notes. I will give it.
Okay. So this is transmission power plus.
Receive power also we will calculate. What is the transmit power required for the distance? That is also we are calculating it. Okay.
For
For a fiber optic link, for a span, we can say.
link. Okay.
Link is between city end to end point, ultimate city A to city B. That is link. Span means what I was inside a link. There are multiple spans.
Inside a link, there is a multiple span.
Okay. Link means what I this one is city A and this
Okay.
is city B. Final origin, final destination. So, but in between, you installed 2, 3 amplifiers, ILA. Okay,
Okay.
then we have 1, 2, 3, 4 spans are there.
Okay.
Okay, so good question. So it is the difference between link and span. Link.
Okay.
I will fix this.
Link is A to B, but span is between stops.
Yes, I gave you 2 condition. What is the 2 condition?
What conditions?
For span, it can be transmitter. It can be between transmitter to receiver or transmitter to ILA or ILA to transmitter receiver.
Okay. But link is A to B.
A to
Like,
B, end to end,
okay.
where you want to ultimately reach.
So we have to calculate for link then.
Yes.
Okay. The
No, but
budget.
no. You limit with span. We will go with the link after in the final stages.
Okay. So you're saying, so right now, what is our final target? That is what I'm asking.
Link budget.
No, no, no.
Ah,
Okay, budget.
ah,
Budgeting, right?
yes, budgeting.
Okay, okay. So,
Link budget,
so
link
how
power
we
budget.
budget is like,
Yes.
For the link, all
Yes.
these conditions we apply, like
Yes.
transmit power,
Yes. RF
receiver power.
connectivity, all the losses, including optical return loss and dispersion penalty.
Okay, okay. You think it's around everything? How much it gonna be costing? Like approx? Everything has some rate, or how
No,
it will?
budget in the sense, don't go with financial budget. We call
Ah,
this is a financial budget for optical networks.
okay. What is
Okay,
mean by
the
budget?
calculating the either the transmit power or the receiving power is called as optical link budget or optical power budget.
We already did it in the top, right?
Yes, yes, this is the one. Yes. But this
Okay.
is not a complete picture because we didn't do it for a link. We didn't consider other parameters as well. That is what I
Oh,
will tell. Yeah.
okay,
Because
okay.
even though you have a good signal, sometimes the receiver can't able to decode the ones and zeros, understand or recover the ones and zeros. Why? Because there are lot of noises there. We studied in the first three classes why noise was introduced in that one. So noise is also there along with the signal. So we need to we should maintain the signal level as well as the signal quality. So signal level is related to optical link budget or optical power budget, but signal quality is related to a parameter called optical signal to noise ratio. How much good signal is there, how much noise signal is there. That ratio we will study it. And another set of formulas are there. So that
Okay.
is there. And where to keep the amplifiers? We know we need an amplifier, but what is the ideal place to keep the amplifier in the span? So that is also we need to calculate it. So and then we introduced several other components like splitters, couplers, and another type of amplifier is there. So when we introduce these devices into the optical power budgets keep on changing, but everything is plus and minus only, except this OSNR and dispersion penalty. Everything is like straightforward formulas only.
Okay. I'm little bit confused.
Where you got confused.
So the fiber only bears
Ah,
-5 to +5 dB.
yes,
It ranges from there.
yes.
Okay.
Ah,
Why don't we take +5 and just send it?
that's what I said. You by default you want to pump five full
Yeah.
power. Okay. See, if you pump full power here, this glass material will get affected or not. No?
You said it will bear, right?
Yeah, it will bear. But once it is going out of it, it is bearing the full power in the initial direction.
Oh, okay, okay.
So they always go for the optimum level only. How to say? Even though your bike can go in for 150 kilometer per hour, we are not
We
going
drive
in
in
that.
80.
Yeah.
Yeah.
That's a good question. It can be answered in a better way.
Okay. Okay. I got it. Like we have to calculate.
Ah,
We have the ranges, but we have to calculate it
ah,
though.
okay, I will give
All
you
the
one example.
parameters.
The radio station is there, for example. I told you one radio mirchi is there in one city, another radio mirchi is there in another nearby city. So, if you are in the border, it should not mix with each other, correct? So, if you want to reduce your coverage, what you have to do? You have to reduce the power, correct?
Yeah.
Actually, here, overreach one concept is there. So, unnecessarily, they don't want to push more power into any communication device. This is not only applicable for optical. It is applicable for microwave, satellite, everywhere. because if you give unnecessary power, it will shoot beyond that point.
Okay.
Okay, so we will see that because I said yeah, yeah, you are always dealing with spans only. So after this, there will be again it will not interfere with the another segment, next segment.
Okay. Okay.
Hi.
So our final target is we have to calculate
Yeah.
transmission power
No,
with all the parameters.
yes, yes, sir.
Okay. Okay. Okay, sir.
But I will give the good answer for it. Why we can't go for a full power now? But actually, that is not. But I will give you a concrete explanation for that. You make a note of it. This one and DBDBM.
Yeah, DBDBM main. Yeah, the calculation you're saying, but the real calculations,
Yeah, yeah.
yeah.
With one example, we will see that.
Actually, we have to convert into DB. If it is DBM, we have to convert into DB. But you are saying put like that, right?
No, it is not like that. I will show that. I have the same doubt. 1 year before only I cleared why we are using logarithm. One day I was sitting idle and asked why we use Fourier transform, why we use logarithm. With ChatGPT, I was keep on asking, and then I understood why this one. And I have several other doubts also, like symmetric filter, asymmetric filter, why we are using both. And so I got it cleared, but I can uh, find out the right numerical example so we can do it. No?
Okay, okay, sir. Yeah.
So what we have studied, I will give, based on this, I will give you five formulas, say, sorry, five problems. Okay.
Okay.
Within this ranges only, no extra concept, no loss, dispersion penalty, what else? RX sensitivity. But RX sensitivity, I will give you a table. You need to find out the correct value. Okay.
Okay. And till I'm not sure I got the dispersion penalty.
Why? What happened?
Because like where we have to add this in the transmission power.
Oh, okay. That is you have to add with the loss. Wherever you are adding the loss, this overall dispersion penalty all comes in the loss. I will give you the full formula, complete
Okay,
figure
okay,
form. Uh,
okay, okay.
uh, where is our formula?
This top,
Here.
yeah.
Yeah. In the total loss, you need to keep adding it. So it is simple as long as this one. Only this part is calculating dispersion penalty is tough because
Difficult.
of the yeah.
Yeah, yeah, yeah. Okay, Surendran.
Okay, next class you should do and you have to share the don't do ChatGPT.
Okay, okay.
Uh,
I have to do my with my hands. Okay.
yeah, calculator
Okay,
in hand.
okay,
Uh, okay,
okay.
then we will
Yeah.
see next class. I will update you. Keep on updating you tomorrow. Depends on the situation.
Okay. The formulas where you will put.
I will post the notes and I will give the formulas as well along with the thing. I will keep it here now, in the Google Drive.
Okay.
Say I will create a folder here. I will create a folder for you. Uh, uh,
Mm. The whiteboard sheets, right?
Whiteboard sheet. It is there.
Yeah, yeah. But then I mean, a little bit in the middle, I lost the touch with this recording, but I will watch this recording actually
Yes.
before the class. So no
You,
problem. No, you don't have to again explain
uh,
me. So I'll watch the recording.
uh,
So no,
I will
so
pay
yeah.
mass exercise. I will paste it here.
Okay.
You don't do
Also,
ChatGPT
you
because
paste there, right?
yeah, you can do ChatGPT. You can correct the answers. You can find this one. But when you are explaining it to me, you should explain logically.
Yeah, 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 sure, sure, sure.
Hmm. Okay, I will keep that in this folder along with formulas, reference sheet. Yeah.
Okay, okay. Okay, Surendran.
Okay.
Yeah.
Sundrin, I'll call you after some time.
Okay. Okay. No worries, take your time, Harish. No.
Okay. Okay.
And one question, Surendra,
Yes,
like
sir.
when will start to apply the jobs?
We'll finish this Friday. That tomorrow we will see that QGAS part. So because that is pending, if we finish that, you will get some. You covered one good portion for OSP. Okay.
Okay.
So you can confidently apply for these cases. Now you know that the connector, you saw that fiber materials and all. I'll give you some more YouTube videos how the fiber looks like that. So we can
Okay.
target the OSP jobs now. So
Yeah.
Monday onwards we will be ready, particularly this optical case now. So before
Okay.
that, this Thursday and Friday or Saturday till that time we will see the QGAS thing.
Okay, Surendran. And also, my question, um, uh, like, how many years does it require for getting a good job in OSP?
No, no, years is not a matter here. I not like India. See, I am 20 years after my in Infosys. If you look at my profile, they said entry network level engineer. That is my.
Uh, I got it, but I
It's
when
depend
I
on the
was
application. Yeah, you even 2 years is enough because there are a lot of entry level roles are there in US now.
okay, but when I see the jobs in data engineering and the other things, I don't see any jobs.
I told you, no, my friend, this fellow, he used to ask me 7 years of AI engineer experience. I told him that AI itself comes 5, 6 years before only. Even though it comes 10 years before, people came to know in 2023 only. We
Yeah,
came to college on 2022. Without
yeah,
ChatGPT, we completed 1.5 semesters.
yeah,
Uh, uh, how come you get a data engineer for with 5, 6, 7 years experience in the market? Even if you get it, it will be a fake thing only. So,
yeah,
but later on, they took 2 years, 3 years people only. But just like that, they post 7 years, 8 years, and all. See, your Vivek is a good example. 3 years,
yeah,
then they modified him to 2 years. Na.
yeah,
One and
yeah,
a half year. Na. He not even have 2 years.
yeah.
The good part is you can find so many data engineers, but you can't find the OSP engineer, fiber engineer um, in your this one. So that's why I ask you to go for one exercise, OSP engineer, network engineer. How many roles are there for OSP and the network, and how many people by average they are applying for it? You can ask your deep search. No, give one
Yeah,
website, Dice or Indeed to Google Deep Search.
yeah.
And for your convenience, you tell me tomorrow what is how many applicants and an average comes to one position in telecom.
Okay, okay, so
Don't worry, sir. Still, you don't worry about the job market. Na. So we come one optical good part optical completed it. You just study that those things whatever is there. We will keep
yeah,
going.
yeah. I'm getting fear as well because like
No,
the
you are
days are
progressing
going
really.
like water. Actually,
You are
March
taking things
came.
very good. Na. Actually, I feel that you are a best fit. Even today morning, I was thinking, I was talking to my wife that it was time management is very difficult for me to run the class. I thought I was telling her whether I will leave the class, will refund the money to people. And then I thought because of you are very interested, so that's why I don't want to quit it.
Yeah.
Because
Okay.
you it is very interactive. You ask see, today also two three questions you blocked me
Okay.
so that is very good no? See this and all I never think it in the way why can't we go for a full 5 dB power no? Honestly I don't have a right answer no? I will search for it no?
Okay.
No worry, you are in a good shape. I'm sure you will get a very good job. Don't worry about it. That I will take it as a challenge.
Okay, Surendra. Yeah. Yeah, bit like my stem is coming. That's my main concern.
I understood. I
I
understood.
was trying in this other way also, like for investment and all. I don't find any investors.
Hmm.
And also, I was trying for the joining the consultants.
Uh,
Everything I'm doing, I know these consultants and all bullshit, but somewhat, some might need the right persons.
uh,
Yeah. What about the your friend? I have a
no, I gave his your CV to data architect. He said he will forward to the client. If client said okay, then he said he will come back to me.
okay. I only kept like only 2.5 years experience only.
That he said that 3 years is required for that one.
Oh,
He said let me try my best because he don't have candidate. He will push him because if you get a guy, he is going to get paid. No,
yeah.
so that guy used to push everyone.
Okay. He's a vendor.
No, it's typical another your guy only, AP guy only. He's running a consultancy. His job is don't have office and all. He just send people to big companies. He have two, three good companies, Mastercard, AbbVie.
Okay.
So even I got a offer, but that fellow is a greedy fellow. If he get 120, he will give 40 to us. No.
120. How much is it?
40.
Oh, that's very bad. This all and
Our fellows are that too. I sent for the 4 5 people to him. I didn't
yeah.
join with him. He was very upset. But later on, since I am giving CV, so whenever he need people, he came back to me.
Okay.
I went for PM position. For PM position also, he said 40 only. But my friend, I got my friend who was already working with him. He only referred me.
Okay.
So, he for me he is give but $40 only.
Okay.
Why to $40? No insurance. Why should I jump from here to there? No?
Yeah. What we can do, Surendran? They are playing with
Actually,
us.
I realized it, and they have our people know.
Yeah.
They have created a kind of a mafia. So they everyone have 5 to 10 companies in their kitty. So we can't enter into those organizations without these people.
Yeah.
In his name, AbbVie. AbbVie is a big biomedical company in Boston. Uh,
Mm-hmm.
Actually, they found medicine cure for cancer also. They patented it. Uh,
Mm-hmm.
but unfortunately, they were stuck up with this guy. What he did, all your guys, AP guys, they formed different company and attacked the same organization. So
Uh-huh.
AbbVie thinks he has 5 vendors, but all 5 are these people only. They are
Okay.
they form floated different LLCs, INCs, and
Mm-hmm.
then within themselves they send the people. So if a guy like you who wants to join AbbVie, even if AbbVie post an ad, without these guys you can't enter into them, no? Enter into their uh,
Yeah.
job portal, interview. But even if it is a worst resume, this fellows will do all the manipulations and convince the customer to go for an interview.
Mm.
I gave 4 5 people. He doesn't have a courtesy to say thanks or at least if we gave $500 for a person, I would have closed my credit card. No, and even he knows that I don't have H1B. This fellow is sponsoring for my all my other friends, but he never asked me whether I will help you out or not. No. Well, I just kept him because in future, if something happened to me, or people are just like that, if anyone is there not getting job, we can refer to him. At least in one way, it's helping someone. That's why I kept.
Yeah.
But that is brutal. brutal. Like Mastercard also with him only. Mastercard, Citibank. If you are going as a programmer, technical engineer role, without these guys' knowledge, you can't get an interview from those people.
Yeah, I know. These all guys have the um, access to the job portals actually, you know.
One African American, he was laid off in Infosys. He was with my project. He's a software
Uh,
guy, actually.
mm,
I referred him, he got selected, and yesterday he called me and said, hey, he is a non-Indian. How can I tell my conditions to him, whether he will take it seriously and complain to someone else? Because he won't give every bi-weekly salary, he will give monthly salary, and he will do all, not, my friend used to tell, $40 he will give in, $50 he give you, and then
uh,
you have to give him back that $5. $5 means per hour. You got
okay.
my point?
Yeah, yeah, yeah.
Mhm. He will pay you $50. 1 month means 160 into $50. But you have to give him back 160 into $5 back to him,
Okay.
either by cash.
Okay.
That means he is cheating his own company, his own friends itself. Na. By
Mm,
bill, he shows his friends that we are giving $50, $120 we are getting from AbbVie, we are giving $50, $70 is profit for company, but out of that 70, this $5 he's hiding it from his friends.
yeah. Yeah, but people will go because you know you
Oh,
are in
God.
that level where you can like you can switch, you can get a good job, and you can have a good experience and all. But people like me,
Yeah.
they have no options actually, you know.
We become the target, yes. Even for me, what he did, for every people, almost four people I recommended to him. For
Mm,
all four people, obviously, they don't have experience like 1 year, 2 year, like your case only. So
mm.
he did the background check. He manipulated it and he cleared it for all the people.
Yeah, they will do that.
Uh, Even my friend actually, he was here. He had ganja 1 week before, and he got the medicine urine test. Uh,
Mm,
this fellow, just like that, he's telling you take the urine sample from your friend and swap it in the Quest Diagnostics. Na.
yeah.
He's giving that idea na, to uh, so for me, he said, don't do the background check application form because the application form was sent by a third party. The app we send gives it to third party. This fellow had a tie-up with that third party. So
Yeah,
he thought, I said, I have did so many background checks because I switched 2, 3 jobs. I was doing some part-time jobs, so everywhere they
yeah.
did the background check. So my record is pretty clean. You don't need to do it. So, but that fellow was keep on insisting me to share the username and password. I did it on my own, and he was very furious. He said, if it is rejected, then I lose money. I said, no, you will. I will not get rejected because in
Uh,
Infosys, whenever I change the project, also I need to undergo the background check. So
uh-huh.
nothing will go wrong. But instantly it got cleared. Then I realized, okay, at this stage, I will not take risk with this fellow. No.
Okay. Mm. Okay, let's see, Surendran, how it will go.
Oh, everything is recorded. Ah.
Oh. Mm.
No, no worry. In communication, it is not like there. In networking, it is there. Fiber telecom, it is not there. Our people are not there in that much level.
Okay. Telecom means networking only, right?
Yes, all the networking is there everywhere. Even in you can find it in a hospital, theater, everywhere.
Okay.
Food restaurant, all those.
Oh, that is the reason why I joined this course. Yeah, I did a little bit research, like how
Okay.
the jobs are there. That's good. And I asked Vivek also, he said it's good. And I joined. I took care. Like, right now, learning is very difficult for me.
Understood. But you remember all those things. That is very, very good actually.
Yeah.